Hey ladies and gentlemen, this time around, let's learn how to measure resistance with the multimeter. So our questions are basically the same as last time when we were measuring voltage. So we want to answer with how to measure resistance, and we're going to relate this also to continuity because they're both directly related. Is what do we actually switch the dial to on the multimeter? What is the multimeter actually doing? Like, what is the instrument doing when it's measuring resistance? That will actually help us understand why we do certain things with the rest of these questions. So should the circuit power be on or off? Should it be connected or not connected? And then where do you actually put the leads? So let's take a look at our circuit here. And we're still using the same circuit, this simple series circuit. We got our multimeter. In terms of where should we change the dial to measure resistance? Where should we change the dial to measure resistance? So if you said in this green area down here, you are 100% correct. And we will talk about in a second here which number we think we should change it to. But first I want you to think about, or I want you to listen as to what does this multimeter actually do when it's measuring resistance. So we have these leads. We have it switched to resistance. What this multimeter will do now is it will send out a current from one side to then go through to the other side and then back in the instrument. And then the instrument, so it's a precise instrument, this is a very precise meter, it's going to measure and it's going to be able to tell what was the resistance of what it sent that current through. That's how it does that. And the same thing with checking continuity. Continuity just means, is there a continuation of the circuit? Is the circuit connected? Will it allow the electricity to flow through? So, and then the way that it checks continuity is then, hey, let's pump some current through and see if it makes it back around. So in terms of our circuit, that means if our instrument is sending out current and it's trying to measure how much current it sent out, that means that we should not have our circuit powered. Because if this is powered, it's going to be pumping out current, and then this is going to be pumping out current. So then it's like the machine can't really measure its own current because the current that this is pumping out is going to mess it up and so on. So our circuit needs to be off. Anytime you're measuring resistance, turn the circuit off. You got to unplug it. Next step, in terms of our circuit, should it be connected or not connected? So in general, it depends on, again, it kind of depends on what you're measuring the resistance of. And in terms of when you're measuring resistance, you should be just measuring resistance of a certain section of your circuit. So in general, you disconnect the circuit. You isolate the part that you want to measure the resistance of. So let's say I want to measure the resistance of this section right here. So from this beginning to here. So if I want to measure from here to here, I don't leave that connected. I don't just, this is not proper. I don't go from here to here. That's not the right way to do it. What I need to do is I need to disconnect from here, and then from here, I'm isolating the section that I want to measure. I want to measure this section and see if it actually works. Or I want to see what the resistance is. So we established that we should isolate the section that we want to check the resistance of, or that we want to check the continuity of. So now if we look at this resistor, that resistor says 100. So we're expecting 100 ohms. So if we do a reading and we get 1,000 ohms, well then that means that that thing is definitely not working very well because the resistance would be way higher. If we do a reading and we get 50 ohms, then that's not good either because that's too low. That means there's something wrong with this thing. So what we want to do is we want to put the multimeter on the correct setting. So now this is my question for you. I'm going to read these numbers here, and you're going to then answer. Which number should then if we're expecting 100, which number should we set this to? So this says 2 million. We call it 2 mega, but it's basically 2 million ohms. This here is 200K. K means 1,000, so 200 times 1,000 would then be 200,000. This is 20K, so that would be 20,000. 2K, 2 times 1,000 is 2,000. And then here's 200. So what setting should we set our multimeter to measure if we're expecting 100 ohms? So if we're expecting to measure 100 ohms, we of course will put it down to 200 because that's the nearest one that is just directly above 100. one thing I can do just to check and make sure is I can put my leads together and make sure that my multimeter is actually working. So there, I'm getting a number on the multimeter, a very, very low number, because it should be very, very low resistance right now, because right now it's just heading through the wires. I take it apart, there is no continuity, so that number 1 shows up. So if we put our multimeter leads on the ends, so we put them on the ends of the circuit, of the section that we isolated, and we should get a reading. And if you look there, we got about 95, which is within spec. 95, very close to 100. So that is within spec for this 100 ohm resistor. Let's try a couple other resistors and plug those in and see what numbers we also switch the dial to on the multimeter. So this resistor says 1K, so that's 1,000. So in terms of my question to you is where should we move the dial if we're expecting to measure around 1,000 ohms? Where on this dial should we then turn the multimeter to? So if you said 2,000, that is correct. Let's check it out. Let's see how accurate or how close this resistor is to being to 2,000. I'm sorry, 1,000. So if we try it out, this resistor, notice how it says 0.9? What that actually is that's 900, because 2, so if it was 1,000, it'd show up as 1 point whatever, 1.0, 1 point whatever. But this is under 1,000, so that's why it's showing up as 0.9. So that's 950-ish ohms, and you can kind of see it's kind of bouncing a little bit. This resistor is at 5.1K. So where on our multimeter, where would we switch the dial to? The last thing to show you here is about continuity. So that's what we'd switch the multimeter to if we're trying to determine if there's continuity. Basically, that's what that's saying is, hey, does the electricity flow through this section? Will it flow through this wire? So it's mainly if you're checking wires and so on. So this would be our wire. It's very good for checking if you have like a broken wire, like maybe, again, like I keep going back to vehicle, type things. Those wires bounce around, they get weathered, those types of things. RC car type stuff, whatever. So I have it switched to continuity. I put one lead on one side. I put one lead on the other. I'm trying to make sure my fingers don't touch the actual metal. Not because I'm going to get electrocuted per se right now, but because I don't want to affect the reading. So you might be able to just barely hear it. It's making a high-pitched whining noise. What that means is that we do have continuity. And if I go like this, we can hear it as well, or you can see that the multimeter changes. So there's continuity. That's a very, very nice way to check and see if does the circuit continue. Is there a continuation from point A to point B? And that's really, in terms of how we set this up, it's the same way as we would set it up for measuring resistance in terms of the power's off and those types of things. So here, to summarize this lesson, some questions again for you. For the power of our circuit, should the power be on or off?